Welcome back. My name is Mr. Monty, and this is going to be lesson 3 in our 2020 series in preparation for the college placement exams here at the community colleges of Spokane. Today, we're going to start a series of lessons that talk about domain and range. We're going to continue what we started in lessons 1 and 2, using our data table and trying to find coordinate points so we can sketch the curve. Now, depending on where you're taking these placement exams or in your actual classroom tests, the type of calculator that you can use. At the community colleges here in Spokane, they only allow you to use technology up to a TI-30, so we won't be using a graphing calculator. That's why we're actually going to calculate some actual points in case you're not sure what the given function looks like ahead of time. So let's get started. Our I can statement today is, given a function, I can tell what the domain and range is. My first step, using our 3-column data table, I want to actually calculate some coordinate points so we can get an idea of what this shape looks like. I'm going to pick 4 arbitrary points. Well, I've got 5 here. 5 arbitrary points, and here's our given function, x raised to the second power, or x squared. Minus 3. I'm going to put a minus 3 squared. Well, that's the same as minus 3 times minus 3. So we're going to get a 9. Our first coordinate point, minus 3, comma 9. Arbitrary value number 2, minus 1 squared. Minus 1 times minus 1 gives us a 1. Our second point, minus 1, comma 1. 0. Let's plug a 0 in for x. 0 times 0 is 0. 0, comma 0. Our fourth point, 1 squared, raised to the second power. 1 times 1 gives us 1. Our fifth point, 3. 3 raised to the second power, or 3 squared, gives us 9. So we have 3, comma 9. Let's take a moment and take these 5 points and put them on our grid and see what we come up with. Minus 3, 9. Our first point, minus 1, 1, 0, 0. Goes through the origin, 1, 1. In our last point, 3, we already have the 9. We can see that we have some sort of, as we connect the dots, a bowl shape. Always make sure that if we're given a function and we don't have any restrictions on it, it goes on forever in both directions. Okay, now let's take a moment and answer some questions before we actually get to what we were trying to do, which was domain and range. The family of functions. Well, let's take a look at our actual function here. We have x raised to a power. That's our first clue. It's a power function. But in more common terms, we can see the shape is a quadratic. And then the common name for this shape is a parabola. So the family of functions, there's actually 3 different words we could use. Power, quadratic, or the actual shape of this one called a parabola. Our y-intercept. As we go through these 20 lessons, you're going to hear y-intercept referred to a lot. Let's make sure we label the y-intercept in this particular problem. y-intercept was 0, 0. Okay, now let's talk about domain. The domain refers to all the possible x values that satisfy this function. What x's can we put in there? We're talking about the x's in the negative direction, the x's in the positive direction. Now we didn't actually do it on our grid, our data table here, but let's picture if I put a really, really big x value in here, am I going to get a y out? Yes, because it goes on forever. So I can actually say all real numbers, or in math terms we could write from minus infinity less than or equal to x, which is less than or equal to positive infinity. Now let's talk about the range, the y values. Now this one's a little bit trickier, and this is why I always like to make sure I sketch it so I can picture what's happening. What we want to find is the outputs. For all the given x's that we put in, we do the operation, what is the output? What is the result? In this case, we see this bowl shape. Let's think positive numbers. Let's do the easy one first. Positive x's. For really big positive x's, what comes out? So the bigger this gets, the bigger the y. The bigger the y. So we know we have positive values of y. Yeah. So I'm going to write two different things. We know we can get positive big numbers out. What about when we had negative x's? When we're way out here in the minus range, this was positive. So we had positive here also. If we looked at the grid, what's the smallest y value I ever get out? We could actually put a little dotted line right here and say that we don't get any of these numbers down here. No negatives come out. It starts at what? What is this line called? Well, this is the y equals 0 line. So it started at 0, and we actually got a value at y equals 0, and up. How can we write that? Y has to be greater than or equal to 0 up to infinity. So in words, y is greater than or equal to 0 up to infinity. Or we can rewrite that as 0 less than or equal to y less than or equal to positive infinity. Make sure you check with your teacher on how they would like you to actually write this in proper terms so that you can get full credit, whether it's a homework assignment or an assessment. Well, I think this concludes lesson 3, which was I can, given a function, write the domain and range. And in this case, for the quadratic formula of x squared, we saw that the domain was all real numbers, and the range was from y is greater than or equal to 0 up to infinity. So 0 less than or equal to y less than or equal to infinity. See you for lesson 4.